Okay, so our next question is Fibonacci series up to nth term. Now what is Fibonacci series? So Fibonacci series is a number series, a number pattern which was discovered when scientists were analyzing the population of rabbits. Okay, now why, how, you can read about it on the internet. Now let's see how we can solve the problem. See, what I will do, I will delete this title first and let's see what Fibonacci series is. Okay, now Fibonacci series starts from 0 and 1. So these two numbers are always same. After that, every number is sum of previous two numbers. So after that, let's say 0 plus 1 is 1, then we have 1 plus 1 is 2, then we have 3, 5, 8 plus 5 is 13, 13 plus 8 is 21. Okay, so this number series will go up to infinity. Okay, and the question here is we have given number n equal to, let's say, 9 in our case. Okay, now we need to print out all the numbers starting from the zeroth index up to the ninth number. Okay, so 1 2 3 4 5 6 7 8 9. We need to print all these numbers. We know that the number given is 9. Okay, so 9 is any number. You can give any number to it. Okay, this is the predefined input. You can also give any user input as well. Okay, now we also know that the two numbers, the starting two numbers are always 0 and 1, So what we can do, we can assign a variable to it. So a equal to 0 and b equal to 1, a temporary variable which will initially store the two values. Okay, now let's see, we have a next number, always next number will be 0 for the first time, because see, we are calculating each number after these two numbers, after this 0 and 1, we are calculating each number. So we need to store it somewhere, right? So c equal to 0. Okay, now what we will do, see, we have numbers like 0, 1, 1, 2, 3, 4, 5, 6, 5, 8, and the number is 9. We know that 0 and 1 are always two numbers. So we can skip this step. And after this number, up to this number, we can apply a loop. Okay. So what we can do, we can start a loop from I equal to 2 up to I equal to the nth term, the ninth term. And I will do the I plus plus. Now we need to do something here. So that every next number is calculated and printed at the same time. Okay, now let's see how we can do this. We have a number 0 and 1. Okay, and initially 0 is assigned to A and 1 is assigned to B. Let's say we have a number C. So how to calculate it? And I told you the next number is the sum of previous two numbers. So next numbers, I will erase this. So next number C equal to the sum of previous two numbers, A plus B. I hope you get this. And see, we know that these two numbers are same, right? That's why what we can do, we can simply print it first, because our end goal is to print all the numbers starting from the 0 to the nth term, right? We have calculated the next number. What we can do, we can simply print out the C and our work is done. Really, I hope you might be thinking that the work is done here, but not, because the variable A and B are still the same. They have not changed. So let's say we have calculated C, which is 1, which is fair. 0 plus 1 is 1. But what after that? Next term will again 1. Next term will be 1. And we don't need this, because our number series looks like this. So 0, 1, 1, 2, 3, 5, 8, right? Like that. Okay. Now the thing is, the two values, the previous two values, see, remember the term. The next term is the sum of previous two numbers. So I have a laser pointer here. See, these two numbers are constant. Okay. For this number, the previous two numbers are this. Right? For this number, the previous two numbers are this. And you may have noticed that the 0 is changed to 1, the variable is changed to 1, and 1 is changed to the new number that is calculated. For this number, the previous two numbers are this, and this will go on. So we need to change the variable A and B. So what will be the new values for A and B? So A will be initialized what B value has. So what we can do, we can initialize this like the value of B will be stored in A, and the value of B, the value of C, that is the new calculated number, is stored in the B. And this is how all the numbers in the series will be printed out. Okay, now there is an use case for the Fibonacci series problem, that is finding the nth term. So instead of printing out all the numbers, we need to find the nth term number. Okay, now let's see how we can do it. What I will do, I will just delete this title and I will bring out the code here. That's what we have written in the previous Fibonacci series problem. Okay, so this was our code, right? We used to do, let me get a laser pointer. See, we let's say we have a number n equal to 9th, so nth term. Okay, we have number A and B, that is these two numbers are constant, always constant for the Fibonacci series pattern. Then we used to print out this A and B. After that, we used to calculate all the numbers from 2 to the nth term. Okay, so C is the sum of previous two numbers, so next number is always equal to sum of previous two numbers. We used to print out the C, the calculated number, and the new values of A and B will be shifted to B and C. The C is newly calculated number. So this was our solution. Now how we can modify it according to our problem. So let's see what we can do here. We can define a function fib here, which will take n, so nth term, and we don't need this n equal to 9 for now, okay, because we have already n here. So what we can do, we have A equal to 0, B equal to 1. We don't need to print anything here, anything. After that, we know that C equal to A and B, after this loop will get completed. So C will contain the nth term value. How to call it, how to call the function. So let's say we have given n equal to 9. Okay, and what we can do, we can simply print out the nth term by calling just the function. Okay, so we can just call the function, it will going to return the C, the calculated value, and the answer will be printed out. So this is the result. Okay, so thanks for watching. Hey, there is another approach of finding the nth term of Fibonacci series using the recursion concept. Now, recursion concept is important for the interviews, and the technique that I am going to tell you today can be the base for all the recursion related problems, because the approach is similar but the logic is somewhat different. Okay, now let's see what recursion is before getting into implementation part. Okay, so what I will do, I will delete this title. I hope everyone knows about function. So what is a function? So a function is an organized block of code, a reusable code that can be used by calling it. So let's say we are adding two numbers, right? So let's say we have written a function named sum, okay, which is taking two numbers A and B, and it is returning the sum of it, right? So and a function may or may not return values. It depends on the use case. Now, when we define it, after that we can use it by calling the function. And how we can call the function? Similarly, by writing just name. So sum of 2 and 3. So when we call this sum of 2 and 3, it will go here. Okay, it will go here. The A and B will be replaced by 2 and 3. You can think how the execution is done in background, right? So A and B will be replaced by 2 and 3 and will return the value. So this will be calculated, A plus B. What is A plus B here? 2 plus 3. And what is 2 plus 3 is 5. So 5 will be returned. Now the thing is, 5 is returned, but we are not doing anything with the returned value. Okay, we must store it somewhere, right? We cannot use it directly. Another approach of doing this is like we just print it out. Okay, so we just print it out. When we do this, the 5 will be printed on the console. Okay, and if we want to store it in the another variable, let's say, so C equal to sum of 2 and 3. So let's say 8 and 8. Okay, so it will be 16. So the value of C will be 16 after the function execution completion. Okay. Now, recursion is a concept where function calls itself again and again until some condition is met. Okay, so let's say we are dealing with Fibonacci functions here. So let's say we have a fib function. This fib function can call again multiple fib functions. Okay, so it can have a multiple function calls. This fib function can again have multiple function calls, and this tree like structure will grow indefinitely, but until some condition is met. So why I told you this? Because when a function execute starts, it will start executing and it should end somewhere. Okay, so let's say we have a return fib here. This function call must finish its execution. After the execution, it will vanish and this branch will be deleted. This is not legit branch, but for explanation purpose, I'm telling you this. Okay. Similarly for this, if its function execution completed, it will vanish. Okay. This will vanish. This will vanish. This will vanish until some point will come. Where the function execution has started, it will come to the original position. So this function has executed. This function has executed. Okay. This function has executed. After that, the last function will execute and you will get some value. You will get some value in return. Okay, that will be the final value. I hope you got the logic. Now let's get back to the Fibonacci series. The Fibonacci series, we all know that the starting numbers are 0 and 1. Then next number is the sum of previous two numbers. So 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, and this series will go indefinitely up to infinity. Okay, we need to solve this question, that is finding the nth term using the recursion concept. So let's say we have written fib function here, and what it will do, it will take n as an input because ultimately we need to find the nth term. Okay, now remember the concept. A base condition will come here, and at last it will return something. And as I told you, the next number is always the sum of previous two numbers. So let's say the current number is n. So previous two numbers will be n minus 1 and n minus 2. I hope you got it. Okay, so let's say the number is 2. So previous two numbers are 0 and 1. Okay, now what we can write like this. So fib of n minus 1 plus fib of n minus 2. And as I told you, recursion is a concept where a function calls itself, and here we are calling the function with different parameters. There should remain a base condition which should satisfy and the function execution will complete. That base condition is if my n is 0 or 1. Okay, this is the condition. See, if the starting number is 0 and the second number is 1, it should return the same value because the starting numbers are 0 and 1. Okay, that is fib of 0 is 0 and fib of 1 is 1, and that is our use case, right? So if this is 0, what we will do, we will just return n. So this will be our solution. See, let's take an example of fib of 4. What will happen according to our function, this fib of 4 will check first if n equal to 0 or n equal to 1. So here our n is 4. So the condition will fail and it will return two things. That is two function call. So this function call will be fib of n minus 1. So 4 minus 1 is 3 and fib of 4 minus 2 is 2. Okay. Now what will happen here, fib of 3 will again check for n equal to 0 or n equal to 1, and it will fail and it will return two things. That is fib of n minus 1, that is 3 minus 1 is 2, and fib of 3 minus 2 is 1. Similarly, here it will return fib of 1 and fib of 0. Okay. Now this will return fib of 0 and fib of 1. Okay. See, the function execution is it's almost completed. Now what will happen here, the fib of 0 will return 1. So this will give the value 1, and this will give the value 0 and this will give the value 1. Okay, this function call will return one value, this will return one value, this will return 0 value. So what will happen, 0 plus 1 is 1, and both the function execution will complete, and the fib of 2, the value will be returned to fib of 2 will be 1, and the value that is returned to fib of 2 is 1. Similarly, see, 1 plus 1 is 2, so the value returned to fib of 3, the function call here is 2. Okay, So the function call is 2. And 1 plus 0 is 1. So the value returned to the fib of 2 function call is 1. And this function calls will be executed. After that, 2 plus 1 is 3. This function call will execute and the final value will be 3, which will be returned to the fib of 4, and it will return to the function call where we have written the 4. Okay, it will return the value. Now let's try to incorporate this into actual code.
Okay, now let's code the Fibonacci series problem, and here we will be printing all the Fibonacci series numbers up to the nth number. Okay, so for that I will need a n variable, and I have taken the n, and I will need the starting two variables are a and b, so I have declared and initialized a and b with 0 and 1 because starting numbers are 0 and 1, right? And in Fibonacci series, the next number, that is next term, is always equal to sum of previous two numbers. So I will need to have the next term stored somewhere, so I will use c and I will initialize to 0 here. I have taken the input from the user, okay, using the cin method that we have. Okay, so I will print the first two numbers, starting number 0 and 1. After that, we will start from index 2 and we will go up to the nth term. After each iteration, we will calculate the nth term, the next term, that is c equal to a plus b, and we will print the c. Okay, now the shifting will happen. And each number will going to increase by 1. So here the b value now will be stored in a and the c value will be stored in b. Okay, so shifting will happen and the iteration will continue until the nth term. Okay, and the values will be perfectly fine. So here let's execute it, and I will give an input something like 7. I want up to 7th term. So if you run it, you will get 0, 1, 1, and 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8. So it's working perfectly. Okay. So now there is another use case for it, that is returning or finding the nth term. We don't need to print all the numbers. We just need the nth term number. So let me close this one. Let me copy it. Let me comment it out, and I will just going to paste it here. Okay, so nth term of, let me write nth term of Fibonacci series. Okay, instead of creating function, what we can do, we can directly manipulate things here. So I will need this c out. We don't need to print anything now after this, and we can directly print the c value that we have. And if you try to run this case, if you run this 7, you will get 8. So the 7th term is basically 8, and if you let's say give something like 8th term will be 13, because 8 plus 7 is 13. Okay, and if you give 9, something like that, and you will get output that is 21. Okay, so this is the actual way of finding the nth term. Okay, now there is another use case, or solving the problem using recursion concept. Now recursion is basically a function calls itself until some condition is met. Okay, we will create a function, let's say int fib. So here base condition will be there, and we can return what fib of, let's say n minus 1 plus fib of n minus 2. Okay, because what is the next term? Next term is always the sum of previous two numbers. So after that I can have a semicolon. Okay, so here I will add the base condition. So if n is equal to 1, okay, if my n is equal to 1, then I can return 1 directly. N equal to 0 or n equal to 1, I would say. Okay, cool. So we don't need to do anything. We will take n. There is no need of a, b, c or something like that. We can directly, let's say fib of, and we will pass the number n. Okay, so if you, let me give a semicolon here. So if you try to test it, let me give input 7. So if you run it, okay, we haven't taken the input from the user, so we will need to give input. Okay, because the n was invalid. Okay, so here if we rerun the case, we will get 13 as an output. And if you give 8 as an input, you will get 21. Okay, so this function is perfectly working. Now it's your time to do the code. Thanks for watching.